Now let's differentiate more trigonometric functions, starting with y equals sine of x, cos of x. In this case, we're going to have to use the product rule because we're multiplying sine of x and cos of x. And we're going to be treating them like two distinct functions, f of x and g of x. Okay, so the derivative of sine of x, cos of x. Here's the product rule, of course. So y prime will be f prime of x. And the derivative of sine of x is just cos of x. We're going to multiply that by g of x itself, which is cos of x as well. Then we're going to add f of x, which is sine of x, times g prime of x. And the derivative of cos of x is negative sine of x. Now we can just simplify. Cos of x times cos of x is cos squared of x. Sine of x times negative sine of x will be just minus sine squared of x. And that's as far as we're going to go. That's it. Okay, so what is the derivative of y equals negative tan of x plus 1? Remember, of course, that for y equals the tangent of x, y prime is secant squared of x. Or in other words, 1 over cos squared of x. Okay, but in this case we have an inside function, which I'll call f of x, which is x plus 1. So if we take the derivative of negative tangent of f of x, we're going to have negative secant squared of f of x times the derivative of the inside function, so f prime of x, according to the chain rule. So y prime will be negative secant squared of f of x, which is just x plus 1, times the derivative of the inside function. And the derivative of the derivative of x plus 1 is just 1. So y prime will be negative secant squared of x plus 1 itself. Because 1 times anything is just anything. So we don't need to write the 1 anymore. And this is our answer. There we go.